Welcome everyone. Hello, good morning, good afternoon, good evening, wherever you are. Really happy to have you all here for the final event of the EigenLayer Hackathon. A moment I suppose all of you have been waiting for and have been very hard working for over the past 7, 8, even 9 weeks, because it has been a long hackathon full of a lot of work. And I'm really happy to finally bring this hackathon to a conclusion, and we can have some nice prize awards at the end. We have an exciting event. Please say hello in chat. This is what we have the chat for. We have a lot of people in the audience, so hopefully this event can be one to remember. Nice, everyone popping up in chat. Hello, 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 hello. Right, to kick things off, for those of you that still don't know, and those of you that are coming in to see the final event, we're Encode Club, we're an emerging tech education community. We have been doing this for a long time, and we strive to help you all learn, build, and find your own career path in emerging tech, and continue on. We've been doing this, as I said, for a long time. We've done multiple types of programs, educate series, we've done accelerators, boot camps, we've been helping people with recruitment, and at the current occasion, we are finishing a hackathon that we, as long as everybody else has been participating, has put a lot of hard work into, so that our development community can keep on growing. We're already 500,000 strong, and we keep on growing in both Web2 and Web3 industries. For those of you, as I said, the EigenLayer Hackathon has been a marvelous endeavor on our side. The first EigenLayer Hackathon we've done on our side, one of the very first that you could ever even participate into. It's been quite long. It's been a lot longer than we usually do. 7 weeks long, full of a lot of hard work, a lot of interesting challenges as well. And we are very and extremely happy to have seen the number of projects as well as their quality. And we have some of the judges that took part of the evaluation of the projects along with us to share a few words afterwards. But before that, let me quickly introduce you to Omji Park, who's our head of research and operations at Encode Club, who will also share a few words with all of you. Omji, if you can hear me, welcome to the stage.
I am on the stage. So hello, everyone. Good to see you. It's really nice to see some of familiar faces here. First, well done, everyone, especially all the finalists who made it to this stage today. And also all the people who submitted some project. This was very special one, as Yasin mentioned, one of the very early stage projects ever built on EigenLayer. We know all the challenges you had. We know all the kind of difficult path you went through. Even this is a little bit special that someone who is building AVS, you need even a knowledge beyond the depth. Even perhaps you need to know and understanding protocol itself, or a more of the protocol engineer type. So this was very interesting hackathon for us as well, seeing a lot of different profile of the developers come and then building something cool. And of course, this will not be a last opportunity, so that we will be continuously supporting your journey. Amazing news is some of the projects who are in the hackathon, they decide to going further and keep building, and perhaps someone going to be being a full-fledged startup in very short time. So we are very excited to see a new project getting on the track in this stage. While also we saw a lot of young beginners coming through and try to learn all the concepts, and now they got more into Web3 by understanding risk-taking primitives and further or in general Ethereum itself. So what I want to say is thank you for everyone spending your time. Putting this 7 weeks program was a very, very challenging to update all the amazing workshops, especially all the partners, given that this is really new topic. All of you grinded yourself to provide some amazing content in short time notice. And all the judges spending time with us going through all those projects. Thank you very much. And the last one, of course, all the hackers who participated in learning workshops, giving all the questions and efforts. Either you pass this stage or not. I want to say it's your win that you could build something very, very cool. And even though you didn't win anything this time, please don't give up, continue building, and you will see us very often in your next journey. So everyone, welcome again, and very looking forward to see all the finalists.
Thank you, Omji. Moving on. We would like to send and extend a huge thank you to all the partners that have taken part of this long hackathon through in one way or another, either judging, workshops, helping out with technical feedback, or being on our Discord and providing support for all of our hackers that tried to innovate and build something of great value for the past 8 weeks. We had EigenLayer, we had AutoLayer, Versatus, Authentic, Aligned Layer. We had Brevis, Dune, Automata, Movement, Polymer, Lagrange, Buffer, Ethos, Nia, Layer N, and last but not least, Lemnis Cap. Thank you all. A huge thank you once again for being a part of this journey. The hackathon has received a lot of interesting submissions, and as we've previously said, we've tried to involve multiple judges with different backgrounds, who would go through all of the submissions and pick the 10 finalists that you will be seeing today. There was a lot of great value that was created through all of our projects, and it was not easy for them to pick a final 10 representatives among all the teams that submitted. So these are the representatives of the teams that helped us with the judging, and we will now also have some of them joining us on stage to share a bit of their experience with the hackathon and talk a bit about the teams that were selected today. So let me quickly introduce you to the stage through Nader, Curtis, Yadrin, Sjors, Amrit, and Manav.
Yes. So yeah, my name is Nader. I am the Director of Developer Relations at EigenLayer, and just want to say congratulations for everyone that participated or that won. You're very early in a brand new growing ecosystem, and I think this experience will hopefully, even if you didn't win anything, hopefully help you out in the future and give you more ideas and more potential for you to participate, build stuff in this ecosystem. So really excited to be here, excited and appreciative of Encode and all the sponsors and everyone who participated in this and kind of made it successful. A lot of really great projects that came out of there and a lot of good relationships that came out of there, and more importantly.
Perfect. Curtis?
Hey everybody, I'm Curtis. I'm one of the partners at Electric Capital. Yeah, echoing Nader, really excited to see everyone building in the EigenLayer ecosystem. I'll shill a project of ours called the Developer Report, and we're tracking all the open source repositories. We're going to be adding everybody from the hackathon here, and if we miss you, pull requests are always welcome. So excited to see the pitches later.
Can I just give a quick shout out to Electric Capital Developer Report? You all just do such a fantastic job. Everyone always is sharing those reports, and they're just a huge part of the entire DevRel discussions these days. So awesome work. Excited to see the next one.
Completely agree.
Moving on to you, Yarden.
Yeah. So first, thank you for having us. It's been a great experience. I'm Yarden. I'm the co-founder of Authentic. What we build is a self-deploy infrastructure to spin up the AVSs. Got to see some familiar faces, some projects that we are already working with. Was super exciting to see the level of quality of the project. Super excited to see these novel innovations that are being built using EigenLayer on shared security. Great initiatives. Kudos to the Encode team that ran this amazing hackathon throughout the last few weeks. And always love and happy to think through AVS designs individually, as a team, as Authentic. So great job, everyone, and thank you.
Thanks for the nice words. Moving on to Sjors.
Can you guys hear me? Hello? Okay, cool. Yeah, so my name is Sjors. I'm taking care of all the technical stuff at Lemnis Cap. We are an early stage venture capital firm. I want to thank Encode for organizing the hackathon, all the developers for taking place in the hackathon, and obviously EigenLayer for providing all the technical stack. I've seen a great variety of different projects here, like from cross-chain liquidity layers to creating tooling to make it easier to interact with AVSs or the matching engines, and WASM, even a WASM runtime as an EigenAVS. And I think this really showcases the wide variety of different use cases that are now possible thanks to EigenLayer. So yeah, super excited to be here, and it was absolutely fun to judge all the submissions.
Hey everyone, I'm Manav, and I work on Ethos. Yeah, I just want to say thank you for organizing this, and I just think it's like pretty exciting because a year ago, like EigenLayer was basically just an idea, and it's really cool to see like everyone build like AVSs in like a hackathon now, and this is just gonna explode more and more in the future. And always happy to help even after this hackathon. If you'd like to like reach out to me on Twitter or Telegram or something, like happy to jam on ideas and stuff even later.
Fantastic. Thank you all for the nice words. We will now move on to our next stage, the most exciting stage, really, which is going to be the time for the pitches. So let us quickly transition to our next stage, which is going to be going through all of our teams that you can see on currently on your screen. Is going to be the pitch order for the day, and you will be seeing each team going one after the other, starting off with Fluxlayer.
Hi, everyone. My name is Lecky Lau from team Fluxlayer. We are building omni-chain intent liquidity layer that based on EigenLayer AVS. So cross-chain problems. There's a growing demand on the new networks as technology evolves. There's a roll-up as a service, which push up more roll-ups, such as BTC and ETH-L2. And there's a more diversified VMs, such as Movement, Cosmos, and Polkadot, etc. But the existing solutions cannot address this demand that the first generation leased by Wormhole is in a permission way. And the second generation leased by Stargate has a limitation on the liquidity pool. And that's where it comes in the third generation is the intent that leased by across that currently the number one on the DeFi Llama. In Fluxlayer, what we foresee in the future is intent plus AVS. The intent is still early as Uniswap X only white paper and ERC-7683 only recently published it. And AVS also still early as EigenLayer only recently mainnet. So hackathon implementation, in our demo, we can showcase that we are bridging from Hostkey to Sepolia, from asset A to asset B. So the current system contains components from off-chain and on-chain. On-chain contains order book contract on the source chain and settlement contract on the target chain. And off-chain contains AVS client, which validate fulfillment and submit proof for the taker to unlock the maker's fund. And the aligned layer module helps batching the proof to make claiming more efficient. So firstly, the maker create an order on our AVS off-chain order book. And then the taker sees the order, read it from the AVS and create order on the source chain, which also locks the maker's fund. And then the taker goes to the target chain to fulfill the order, which sends fund from the taker to the maker, which will also trigger transaction verification in the AVS operator. And then the operator will send a signed verification to the aggregator, and aggregator collect once the threshold reach, it will send the response on-chain with the proof that which will unlock the maker's fund to the taker. For the aligned layer, we can improve this process through batching the proof and unlocking the fund in batch. Here's a quick demo video that you can see the front end, the maker can trigger the transfer on-chain, which will pop up the MetaMask to sign with the EIP 712 on the order. And the order will show the full details that for the maker to see. Then the taker can go to read the transaction, read the orders, and submit the order on chain on the host key to create the order, and then fulfillment on the Sepolia, and then the operator on AVS will subscribe for the fulfillment and send the transaction verification to the aggregator, and aggregator will submit the proof on chain to unlock the fund. Future improvement, we can batching the order in the AVS to improve order efficiency. Thank you, everyone.
Thank you, Lecky, and huge applause for you, who's actually joining us in the middle of the night, and which is why he asked us to go on first. Thank you, Lecky, once again for making this pitch, even though it's past 3 a.m. on your end. Moving on to Team EigenWasm.
Thank you.
Hello, everyone. I'm Keisuke from Turingan. a Japanese Web3 company. Today, I'm excited to introduce our project EigenWasm. It is general purpose layer 2 solution on EigenLayer. First of all, I'd like to explain project overview. Our goal is to solve Ethereum issues with scalability and high gas fees. We use WebAssembly, commonly known as WASM, for its efficiency, security, and portability. This enables us to develop flexible and reliable contracts. Additionally, we use fault-proof to transfer execution costs to operators and enhancing scalability. Next, let me explain how it works. We have three key actors in architecture. First, WASM contract. It is flexible, interactive contract compared to WebAssembly. It allows development in multiple languages. Second, WASM contract VM. Operators utilize its VM, and it is inspired by CosmWasm to securely execute these contracts. Third, WASM contract fault-proof. A fault-proof contract on Ethereum verifies the execution result of the WASM contract VM. It is inspired by systems like Canon in optimistic rollups. And then these are use case and benefits. First, verifiable web. It ensures data authenticity and integrity through verifiable computation and cryptographic proofs. Second, fully on-chain game. It enables real-time gameplay and can handle a large user base with frequent transactions. And perpetual DEX. It allows high trading volumes at low cost. Then it can provide an excellent trading experience. Lastly, our project combines WebAssembly and TEE technology to overcome EVM limitations. It's scalable, cost-efficient, and flexible. Here are examples. First, private DEX. It realizes secret position to conceal individual position, allowing for complex strategies. And personal information. It realizes private storage, and high privacy storage ensures that personal information such as ID details, and it remains confidential for digital sovereignty. For more details, please refer to the slide. Thank you. That's all.
Thank you very much. We've enjoyed this. I hope if anybody has any questions, please feel free to voice them in chat. Also, for everyone that's presenting, feel free to also share a few words in the chat section as well for everyone that's watching. Thank you, Keisuke. Moving on to our next presentation, which is CrossAVS.
So, hello everybody, my name is Anirudh, and today I'm going to present my project CrossAVS. So, about myself, I'm a software engineer with 4 years of experience, and I'm into AI and gaming. So, the problem statement that we are working on is to build a platform where Web3 builders can easily build multi-chain apps, and to provide a platform where developers can use the dev tools like SDK and contracts to send messages across different blockchains. So in order to solve this, we are using EigenLayer AVS. So what we are doing here is we are creating two AVS contracts on source chain and destination chain. And using EigenLayer AVS, we will transfer the message from source chain AVS contract to destination chain AVS contract. So we will see that in details. So currently we are focusing on building the cross-chain messaging for movement chain to connect it with the other EVM chains like Optimism and Arbitrum. So this is the simplified architecture of the CrossAVS. So the smart contract will first send the message to the movement AVS contract. So movement is the source chain here. The operator will listen to all the events that are emitting in the movement AVS contract. It will pull the message and it will sign it and send the response to aggregator. Aggregator will push the aggregator info to the destination AVS contract, which is Arbitrum in this case. So this is how the cross chain messaging will work. So this is the small demonstration of how the cross chain messaging will work. So for this demonstration, I'm using single anvil chain, but in actual case, it will be 2 blockchains. So what we are doing here is we are transferring a number from source AVS contract to destination AVS contract. In my second terminal, I'm running a aggregator script. So aggregator is creating a message. So it is creating a message. So currently, in our case, it's a number. So as you can see, it has created 5 as a number. And this will be created in source AVS contract. In my third terminal, I'm running a operator. So as you can see that the operator is currently listening to the source AVS contract. And as you can see that the cross chain message received is 5. So basically in the destination AVS contract, the cross chain message is received. So that was regarding the demonstration. So next is the applications of CrossAVS. So using CrossAVS SDK or contracts, builders can build multi-chain dApps like cross-chain swap and cross-chain NFT marketplace. So that was regarding the CrossAVS. Thank you.
Thank you, Anirudh. Moving you back to the stage. If anybody has any questions, feel free to post in chat. I'm sure Anirudh will follow up. Moving on to our next presentation, which is EigenShift.
Hi, I'm Robert, and I worked with another developer, Juan, to build EigenShift, AVS ticket. So for this hackathon, we actually submitted 2 projects. First is a Golang package, where the purpose of EigenShift is to allow operators to access task generators and aggregators without having to rely on a third party. And the second project we submitted was a price feed aggregator AVS that aggregates multiple Oracle networks and uses EigenShift to aggregate that task data. Our main motivation for building this project, we just wanted to learn more about EigenLayer. So we were reading the white paper and decided to try and build a decentralized Oracle network. Then we realized with every AVS, you either needed to build your own off-chain aggregator or build a custom consensus mechanism. So we decided to solve that problem to reduce the headache for AVS developers. So we have an out-of-the-box Go package to provide that, and also just a way to inspire other people to do it. From a high level, EigenShift is wrapped around a Web 2 consensus protocol named Raft. And this is what allows us we developed a framework around it so that developers can define how tasks are created, aggregated, and submitted on chain only using operators. It uses RPC calls to manage operators communicating with each other. And this package only has 3 external dependencies. That's the EigenLayer SDK, Go Ethereum, and the Raft protocol implementation in Go. And it exposes an interface to allow developers to do all the things aggregators need to do. The actual AVS we built was a simple price feed aggregator with 2 price feeds. This is on Sefolia, ETHUSDC and BTC-USDC. The 2 Oracle networks we use are Chainlink and DIA. These are where the operators actually fetch the price data and aggregates them together. For this AVS, we need a minimum of 3 operators to run. I have a demo of it, but it would take too long to run. One of those operators at any given point will be elected as a leader, and that operator will generate a task and also aggregate the results, and that's powered by EigenShift. This AVS, it runs every 15 seconds to update price feeds, and whenever the price feeds are updated, the leader will change to a different operator. Some of the things we want to build in the future, we want to add test coverage to both projects. I also think it would be cool to show how this can be done using the incredible squaring AVS example, and also to do a testnet deployment of the price feed aggregator AVS. Would be definitely looking for feedback if anyone's interested in using it or inspired by it. Thank you.
So we're Team Gazelle, and we are building an Ethereum consensus secure 2-way Bitcoin Ethereum bridge. So some of the problems we are trying to address is custodian risk, trust assumptions in these custodians, the dormant liquidity problem on the Bitcoin blockchain, the bridge liquidity cold start problem for generalized bridges, the long-term Bitcoin security budget and lack of smart contract expressivity on the Bitcoin blockchain, and the Bitcoin L2 security in the future. So some existing solutions are Wrap Bitcoin, which is currently custodial, Threshold Bitcoin, which uses a separate network security, and RenBTC, which is sunset. With Bitcoin on-chain activity on the rise, with the arrival of runes, inscriptions, BRC20, etc., and the arrival of Bitcoin L2s, there's an increased interest for yield opportunities on native Bitcoin. So how does restaking come into the fold? The operators ensure Bitcoin deposits are credited on the Ethereum mainnet, and that burned GBTC is released from the Bitcoin multisig to the owner. Restakers are slashed in case of malicious behavior. The Gazelle architecture is as follows. So we have Bitcoin multisig on the Bitcoin blockchain, the EigenLayer core contracts, and the two AVS services for bridging from Bitcoin to Ethereum and back. The GBTC or the Gazelle Bitcoin ERC20 contract, the off-chain operators which release and credit the Bitcoin transactions which are sent to the multisig or from the multisig, and Bitcoin Light nodes which are used for processing these operations. We'll now watch a short demo of the application. So first of all, the user has no ERC20 Bitcoin. He'll send the Bitcoin transaction to the Bitcoin multisig. He'll provide the hash of the transaction, and he'll sign it with his Bitcoin private key and input his Ethereum destination address. Once he does that, he'll bridge to the Ethereum chain, and the operators will check that the transaction happened. And if the transaction really happened, they will credit him or mint his Gazelle Bitcoin tokens on the Ethereum mainnet. Here we can see in the wallet that he has been credited with his Gazelle Bitcoin. And the other way around, when he wants to bridge back to Bitcoin, he'll burn his ERC20 representation and input his Bitcoin destination address where he wants the funds to be released from the multisig. The operators will check that the burn really happened and sign their part of the multisig signature to release the funds from the multisig to the user on the Bitcoin blockchain. Using a Bitcoin core node, we can see that the transaction really happened and that the user has a new net amount of Bitcoin which were released from the Ethereum mainnet. And for the future of Gazelle, we would like to introduce native EigenLayer slashing on release, more sophisticated challenge and slashing process, a dynamic multisig with operator entry and exit queues, the use of zero-knowledge proofs for verifying the Bitcoin state, and as future Bitcoin L2s come online, to make them an economic incentive for restakers. Also, the exploration of Bitcoin-backed stablecoin solutions and other DeFi yield opportunities are an opportunity for the use of this bridge. Thank you for your attention, Team Gazelle.
Thank you, Bon, for the great presentation. Moving you back to the stage as we continue to our sixth theme, EigenCow.
Okay, great. Jam, for this hackathon, we'll build EigenCow matching engine powered by EigenLayer and Uniswap v4. The problem with Uniswap v4 hooks architecture is that more complex hooks positions requires frequent hook rebalancing, while traditional methods for rebalancing resulting in high gas fees and price impact. Moreover, uncoordinated rebalancing between different hooks resulting in inefficiencies in multi-hook rebalancing, which is especially vital problem for hooks with complex positions like lending protocols integration, derivatives platforms, or complex yield farming structures. We address these challenges through our EigenCow solution, which looks for off-chain matching of complementary rebalancing needs like coincidence of wants or cow by leveraging EigenLayer AVS for secure execution, while also applying MEV-resistant strategies like batched execution and randomized timing for minimizing value leaks. So how it works? Uniswap v4 hooks submit rebalancing requests to our EigenCow smart contract, which in turn submitted to our EigenCow matching engine. This engine looking for coincidence of wants between these orders and also off-chain order book. Once we have these matched requests, we send them to EigenLayer AVS and after redirected to execution module, which in turn executes all the rebalances procedures on Uniswap v4 core subjective to the restrictions set by developers. Yeah, this resulted in a significantly reduced gas fees due to leveraging this off-chain architecture with our order books. Also, it minimizes price impact by looking for complementary coincidences of wants, which in turn enhance efficiency for not a single hook, but the whole network of hooks, leading to positive liquidity network effect. And also it protects hook developers against MEV, resulting in a much more efficient system. As for use cases, first of all, it's for hooks rebalancing. Also, it can be used for complex yield farming strategies or like liquid staking, token rebalancing, LST or T, also for secure and efficient arbitrage and easy risk management. As for future roadmap, we plan to integrate, beside of just Uniswap Piho, also other meta aggregators like CowSwap, Matcha, etc. Develop more advanced rebalancing algorithm. Also looking for cross-chain capabilities, integrated different chains. So you can think about chain abstraction. So we can also include, for example, spot traders into our network for looking into coincidence of funds. And the last step is probably the most important, is simulation environment for hooks developers, so they can know what to expect from our system. Thank you for your attention.
Thank you, Irfan. Continuing on with our Team 7, NodeZilla.
Hello everyone, my name is Prakhar Oja and I will pitch my project NodeZilla, the king of the node jungle. NodeZilla is an EigenLayer node operator explorer that maintains data for various operator nodes, including buffer finance operator nodes. Overviewing the problem that NodeZilla solves, the problem of maintaining historical data for operator nodes. The current systems and APIs available only fetch and show the current state of the operators. Real-time updates. In the race to fetch and maintain data, users have to refresh to update the state manually. This adds friction as well as lag in the experience. Visualization. Most of the people out there understand things better when they're visually appealing. If only numeric data is provided to non-technical users, they won't understand how to use it. Highlighting your solution. NodeZilla tries to solve all the problems described in the previous slide. It has an appealing front end for non-technical users, a hosted API for technical users who want to fetch or use the historic data maintained by the app, and a graph to help visualize the historical data as a line chart or a pie chart. Moving on to the architecture, we're utilizing MongoDB as a database, Next.js for the front end, Fast API for the backend API, and Dune Analytics for the collector module. As a general flow, user makes a request to the front end for any particular operator, which in turn makes a request to the API, which interacts with the MongoDB database to fetch the historical data for the operator node. The collector module keeps running in the background and utilizes the Dune Analytics API to refresh the historical data for each operator node approximately every 30 seconds. Now, here are some screenshots of the deployed front end. So as you can see, we have a list of operator nodes that are being maintained. We can search for them using their name or address. We're also maintaining the status for the respective operator nodes, that is active or inactive. There's also a toggle button to hide inactive operators. Then there's visualization of the historical data, wherein you can see each strategy highlighted according to their colors, and we can choose to isolate them in the line chart too. And visualizing the current state of the operator node using a pie chart, which highlights the percentage or TVL log for each strategy out of the total TVL. Then the deployed backend API, which has two endpoints, one to fetch all the operator nodes that are being maintained by us and fetch the historical data for each operator node using their address. Now, moving on to the future development. Real-time notifications. Allow users to subscribe to node operators and get notified on their mail for any change in the state or status of the node. And results from data. Using the abundance of data over a period, we can introduce new metrics such as percentage confidence in the operator node and so on. Thank you for listening to the pitch. And this is the link for the deployed frontend if anyone wants to try it.
Thank you, Prakhar. Moving on to our presentation number 8 for today, which is going to be from EigenScan.
Okay, so I will start now. So hi, I'm Sky. So today I'm going to present EigenScans. So EigenScans, what EigenScan is doing is we track real-time and historical events from Buffer Finance and EigenLayer contracts. And we also integrate multiple API And we also provide not health monitorings and email alerts via Grafana. So problem segments. Currently, we have no real-time data and metrics. I mean, we have no real-time data natively tracking the events emitted from the smart contracts. Besides, we have the fragmented data from different sources, and we also face difficulty in monitoring the not health as well. So what we implement is a real-time data pipeline using WebSockets for users to listen events emitted from contracts. So we're currently listening to Power Finance and EigenLayer contracts, their events. So besides, we also embedded Grafana, so utilizing Prometheus and not exporter for not operator monitorings, and we also set up the alerts. Besides, we also develop a unified data layer that consolidates fragmented data from different APIs. So currently, we consolidate Dune Analytics and Eigen Explorer API. So this is a dashboard for real-time monitorings. So this is the metrics. So by collecting the events emitted from contracts, we can summarize this metric and also events. So we also have Grafana node monitoring embedded on our website for user to track the node health. So for email alertings, so we need to have a form for users to collect the users. Okay, so after that, we preset the conditions to trigger alertings. So when Zapier receives the email from Grafana, they can bulk send the email to subscribers. So this is the API aggregator side. For left side is the Power Finance. Power Bulk API is one of the contracts from Power Finance. So we track their events emitted from Power Finance. And for Strategist Manager.so is actually one of the contracts from EigenLayer. So by tracking both their events emitted from their contracts, so we can track the events and metrics. And don't forget, we also integrate with Dune and Eigen Explorer API as well. So for architectures, so for front end, we have the events and metrics, refer to the previous slides, and we also embedded Grafana on our websites. And to utilize this, we also have the database, which is a relational and time series types of database. And for backend, we have several APIs and libraries to track the metrics and events. And don't forget, we have Dockers running as well to track the all the nodes. So for future of EigenScans, we wish to capture more Power Finance events emitted from their contracts. Besides, we also wish to expand our node monitorings to all node operators on EigenLayers. Lastly, we would like to crowdsource the user feedback and build more Grafana monitoring templates as well. So thank you.
Thank you, Sky, for the great presentation. We have just 2 more presentations left for the day. Moving on to Scaffold-AVS.
So I'm presenting Scaffold-AVS. It's a tool I created for this hackathon to quickly create intuitive dashboards for your AVS smart contracts. What's the problem that I'm solving? Well, EigenLayer, as we all know, is new and also quite complex. And there are many good code examples to get started, but they don't have a good UI or front end. So what did I do? I created a tool to help new developers get started on EigenLayer. It's a simple starter kit repo based on Scaffold-AVS, and it includes an intuitive UI to interact with the Hello World AVS, since this is where most new EigenLayer developers start. So there are 2 goals to this project. First, I want to make the Hello World AVS more easy to understand, so it's easier to onboard people to EigenLayer. And also, this tool can be used by developers of any level who are building an AVS and they want to quickly test it using the dashboards. Let's see. I also wrote 2 tutorials that will help developers through all the steps. The first one is how to migrate an existing AVS to the Scaffold repo so you can create dashboards. And the second one is on how to actually create these dashboards. And in these tutorials, I use the Automata multi-proof AVS as an example. So let's quickly run through the demo. So here is the deployed front end for Scaffold-AVS. And I can show you the AVS dashboard. So here on the top left, you can register as an AVS. And if you're registered, you can register as an operator for this AVS. For the sake of time, I already did this. And we can create a task on the AVS. Oh, let's say the task name is called Hackathon. And then I approve the message. And now we can see here in the tasks overview, it shows all the tasks and it shows the new task Hackathon. So I click response, and now this is what the operator does. Here it fills the task name, index, and task created block, and the message that it responds with. So if I click now respond to task, we sign the message, and then we await, and then we confirm, and now it's completed. So basically what this does, you can go through all the steps step by step, and it's visual. So when you're testing something and something breaks, you see exactly where it's breaking and what is breaking. And also there's a debug tab, and here you can interact directly with all the contracts that you deployed or are imported with your AVS. So that's it. And yeah, that's what I built. Thank you for listening.
Thank you, Arjan. Moving you back to the audience as we proceed to our very last presentation for today, which is coming from RewardGuard.
Hello, everyone. I'm Harsh from Team AlphaDesk, and I will be presenting our proposal named RewardGuard to automate a network. RewardGuard is a civil protection solution for reward and airdrops using proof of machinehood. First and foremost, let me talk about the motivation behind this idea and why fair distribution of rewards is a crucial problem to solve in Web3. If you look at few recent examples, such as SAFE and Arbitrum, where protocols have detected more than 20% Sybils, it is evident that current approaches to counter Sybils is not foolproof, neither cost-effective. This leads to reduced trust among community and compromises network security. So, inspired by Shua Zhang Liang from Automata Network, we started to dive deeper into trusted execution environment. Using TEs, we can extend machine-level trust to Ethereum and use proof of machinehood attestations to ensure fairness and legitimacy for distribution of protocol rewards. TEs enable secure execution and provide hardware-level attestations for your on-chain activity. These attestations are then settled on Automata Network to ensure integrity of participating machines. Later, we use verification mechanisms to cross-verify machinehood proofs and filter Sybils from real users. Hence, implementing hardware-level attestations for reward distributions allow us to achieve machine-level trust, which is verifiable on-chain, and it also preserves privacy of network participants. Let's dive deeper and understand how the technical implementation of RewardGuard looks like. A user will interact with different protocols on various networks. With every valid on-chain activity, we submit an attestation to RewardGuard machinehood portal, which relays it to machinehood module, which verifies attestation for different sources. Then this attestation is stored in attestation registry, which later on can be used by protocols to verify legitimacy of users' on-chain activity and filter out Sybils. So to conclude, why did we choose only TEs and proof of machinehood to solve this problem? Answer is, it's scalable and low cost to utilize TEs for proof generation. Also, these proofs are verifiable, which extend trust among networks. And finally, it leads to fair distribution of rewards to early adopters and users, which is the exact problem we were trying to solve. We are Team AlphaDesk, and we are excited for this use case of TEs on Automata Network. Thank you, everyone. Hope you enjoyed this presentation.
Thank you, Harsh. This was great. A fantastic presentation to round off all of the amazing project that we've been showcasing all afternoon. Hope you've all enjoyed these. As we move on to our next section, which is going to be about prizes. So first of all, a huge congratulations once again to all of you that participated in the program altogether. It's been an amazing honor to see how all of you what you all managed to develop and submit. I think the jury was also amazed. You can see this also in the chat section as well. There's been a lot of great projects. You've made it quite hard for them to even narrow it down to 10 teams to present today. To begin with, we'll start off with a general prize, a prize for all of you, the overall prize that all of the finalists today will be getting, and that's going to be the Encode Club prize, which means you're going to be getting free fast tracking to all of our future programs. We'll make sure that you get to participate in everything that you deem interesting. We'll also provide scholarship for all of our upcoming boot camps. And last but not least, the biggest thing, we'll try and provide individual fundraising support to all of you. Starting tomorrow, all of you will get dedicated introductions to members of our team who will try and help you out on your journeys to starting your own companies and assuring you get to raise in the future. As we move on, we will proceed on with the prize rewards from each of our sponsors and their bounties. We will start off with Versatus. Sadly, they were not able to be with us because their representative sadly had to get married today, which was something that we realized quite late. But still, we're very happy to announce the winner for their bounty, which is for building a program on laser with a first place reward of 250 going to the team decentralized voting. So congratulations to team decentralized voting. Hope you're all in the crowd. Well done. And moving on to our next bounty, which is going to be from Automata for building these AVS on EigenLayer beyond multi-power AVSs. I think we have Honor on stage who will come and share a few words and announce the winner of the bounty. Welcome.
Hi everyone, I'm Wana from Automata Network. I'm here on behalf of Dali, who couldn't join. I would like to congratulate everyone who participated, and thank you, the Encode team, for organizing this. And for our bounty, we selected RewardGuard. Good job and good luck.
Congratulations. Congratulations to Team RewardGuard. Well done on your submission and your hard work. First place from Automata. Thank you, Anna, for presenting the prize. Moving on to our next bounty from Movement. And we have Rahat here, who's joining us on stage for the announcement, starting off with the honorary mentions and then moving on to third, second, and first place. As a clarification, the rewards you're seeing with hard rewards when the associated 10K will be in the form of a grant. Welcome, Rahat.
Hey everyone, thank you so much for building on Movement during the hackathon. I'll start with the honorary mentions, which were CrossAVS, decentralized lottery system as well. So thank you both. And on the first, second, third place winners, our first place is Inside Apps. Second place is Win-Win Lottery on Movement, and third place is EigenLayer Dawn.
Congratulations to all the teams and their hard work. Amazing prizes. Hope you enjoyed them. And thank you for joining us.
Yep, thank you all.
Moving on with our next prize, continuing with Dune. And we have Jackie here.
Hello. Thank you, Encode, for hosting this hackathon. I'm really excited to go through all the projects submission, and it was hard to find the winners for this hackathon. So we have 2 times winner, $500 each, and the winners are...
Drum roll!
Decentralized Lottery and CrossAVS. Congratulations.
Congratulations, everyone. And thank you, Jackie, for joining us on stage to commemorate the moment. Thank you so much. Moving on to the Aligned Layer bounty, which is building keys on EigenLayer beyond multi-powered AVSs. We have a single prize to give away. Welcome, Boris.
Hello, thanks for having me. My name is Boris. I'm from the ecosystem team at Aligned. We are a zero-knowledge proof verification layer for Ethereum. We're making zero-knowledge proof verification very cheap and very fast. So this was awesome because this was the first hackathon that we sponsored, and I think we saw something really cool come out of it. We have a CLI and SDKs ready to go and a testnet. We're excited to onboard developers who want to use us to unlock new zero-knowledge proof use cases. And we are happy to award this prize to Fluxlayer. Yeah, there we go. And I just, wanted to say that in addition to using us to verify their proofs, they also built a Python SDK. So super cool stuff. Thank you for the submission and excited to see what else people build.
Thank you, Boris. Thank you for coming on stage. Congratulations to Fluxlayer. Work very well done. Moving on to our very last announcement for today with the prizes from Buffer. Welcome, Amir.
Hey, thank you for actually having us here and Elias participate. Amir, one of the co-founders of Buffer. Maybe I'll just share a quick intro into Puffer and like how we became, like me and my co-founder were both devs. And actually an Ethereum Foundation grant started us off. So we really value participation from our devs, from any dev. We really value your participation. So thank you so much for all who built for us. As you might know, we have recently also announced that we're launching our based rollup ecosystem. Partly what it is used in there comes from the research that got us the Ethereum Foundation grant. Actually, the multi-provers that you guys see today were born out of the 2FA for ZK rollup research piece on ETH Research Post that we collaborated with Justin Drake. So happy to see all of you guys building on TEs now, because back in the day when we did that research, there was a lot of heat against the TEs being unsafe, but it's great to see the adoption like taking off eventually. But yeah, going back to Puffer Unify Stack is a based rollup ecosystem that provides basically same block composability with the L1. You can imagine it can go to this unified ecosystem. You can do your flash loan. You can do swaps on Uniswap. You can do everything and go to another based rollup app chain in one block transaction. So this really excites us on the launch. So looking forward to see you all the devs coming to build there. Also, we are hiring. So let me know if you're interested. Ping me on Twitter, ping me on other places. Happy to chat, happy to onboard. With that, we're going to announce our first place winner.
Let's start off with second or the other way around.
Okay, our second place, our third second place winner is Inside Ops. Our second place winner is EigenScan, and our first place, drumroll, is AVS Node Monitoring. Thank you guys for building on Puffer, and looking forward to actually collaborating with you on much more stuff, including Unify and more to come in the future.
Thank you, Amir. And that marks our last announcement from the bounties and the prizes. So congratulations to all of you that won. A last thing to mention is that all of these prizes are tentative and can be altered. The reason for this is, again, a lot of the teams are still doing due diligence. So if in case something pops up, they might act accordingly. But overall, congratulations once again for some really, really hard work, really, from all of you. Before we continue to commemorate this moment with some nice screenshots to see some smiley faces on the screens, do we have someone from the jury that would like to share a few words? I know we had the jury in previously, but I still see we're quite on time. So if there's anyone from the jury that would really like to share a few words through all the fantastic, really finalists, feel free to say in chat, and we will have you all invited on stage. If not, we're happy to invite everyone. Hey, OMG, hey, everyone, all of the finalists, let's come on stage for a couple of final nice smiley screenshots.
It was very, very, very nice, Paige. I loved it. Curtis, did you like it?
It was awesome.
Do you want to give a few words to our amazing finalists while they're getting invited to stage?
Yeah, I think I'm just pretty impressed by what people were able to accomplish in such a short time. And, it's attributed probably to great documentation and a lot of prior art out there in the open source world. So awesome work, everybody.
Yeah, very happy. All the teams have been working quite hard for the past few days and trying to get their pitches ready as well for this event. So, and we were really, really rushing to make this event run on time, because we know so many teams, so many participants. We wanted to make sure we respect all of your times as well. So, thanks once again to all of the pitches, and also maybe a few words from Shaw.
Yeah, absolutely. So yeah, I echo what. Sorry, I really appreciate all the presentations. It was really nice. It's really amazing how much all the hackers were able to put together in such a short period of time. And yeah, if you guys want, any advice on pitching, on technical feedback as well, feel free to reach out. I will drop my Telegram and Twitter in the chat. And yeah, happy to help always.
Amazing. Cool. Thank you all. And let's final smiles. And so that some of my colleagues can also take some lovely screenshots. Again, we would love to put your smiley faces and promote your projects with this amazing event. So in 3, 2, 1, let me see your best smiles. 3, 2, 1, smile. Thank you all again. Really appreciate your time, both participants, finalists, sponsors, judges, and everyone that took part of making this event possible.
Yeah. Thank you for putting this together. Encode, you guys did a great job. Thank you.
Thank you for support.
Thank you all.
Everyone, we will be all stay in touch. Also, you're going to see us in person in DEF CON as well. Everyone, stay tuned, keep building, keep shipping. And I'm sure some of you are going to be fundraising by then. So let's grind.
Absolutely. See you all. Have a great day.
Yeah, thanks for supporting Puffer.